Okay, section 6.5, finding angles with trigonometry. I hope that by the end of this lesson, you're able to label a triangle with hypotenuse, opposite, and adjacent in relation to the angle of interest, and choose and set up the correct trig ratio to solve for an unknown angle. And I hope that you can draw and label a triangle to represent a given situation. Question number 38. If this computer would work for me. Here we go. So a hot air balloon is flying over a field at an elevation of 100 meters. The landing pad is a horizontal distance of 800 meters away from their current location. At what angle do they need to be looking to see the landing pad? So we can draw a line along here. Here's the landing pad. Oops, there's the balloon. That's probably a poorly drawn line. Let's go a little lower. Something like that. And this distance along the bottom here is 800 meters, the horizontal distance. Okay, horizontal, same as the horizon, should be flat. And they're at an elevation of 100 meters. And what we're looking at is what angle do they need to be looking to see the landing pad. So if we have this line of the horizontal here, what angle do they need to be looking down at to see the landing pad? Now that angle there is the same as this angle here, so we can use either triangle to figure it out. Both of them have the same dimensions. If I look at the lower triangle, first thing I need to do is label my sides based on the angle of interest. And the hypotenuse doesn't care about the angle of interest, but the other two sides do. So straight out would be the opposite. And the one side that's connected to the angle would be the adjacent. So we have opposite and adjacent. We know those pieces of information, and we're looking for an angle this time. So we set up the same trig ratios as we did before. Opposite and adjacent, if we look at SOHCAHTOA, just as a reminder, opposite and adjacent relates to the tangent function. So we would say the tangent of this angle, I'll use theta, that little Greek symbol to represent an angle, is equal to opposite over adjacent. And when we substitute in the values we know, we have the tangent of theta is equal to 100 over 800. So now we've got our equation set up. We were able to draw a diagram based upon the problem given. We took the information we knew and the information we wanted to find and created an equation. So here we go. Now, do you remember when we talked about inverse operations for solving equations? We're now going to try and solve this equation for theta, this unknown value here. But we need to remind ourselves of inverse operations. For example, inverse to addition was subtraction. The inverse to multiplying was dividing. The inverse to squaring was to square rooting. And those functions are very similar to the tangent function. So the inverse of the tangent function is just written as the inverse tangent. This tan with a little -1. And the -1 is just representing that it's the inverse. It is not an exponent. Okay, so it's really important that we recognize that this -1 up here for the tangent is just saying the inverse of the tangent. Let's undo the tangent of this angle. So if we take the inverse tangent of the tangent of theta, those are opposite operations. We'll just be left with theta. And on what we do to the left-hand side, we must also do to the right-hand side. So I must also take the inverse tangent of 100 over 800 on the right-hand side. Now that is a calculation that we can do in our calculator. And just remember that this -1 is not an exponent, it's just telling us the inverse tangent. To undo that, now let's see if I can dig up my Desmos calculator here. So on your calculator, you probably see a button for sine, cosine, and tangent. And if you look at the little writing right above that button, you probably see another button for sine inverse, cos inverse, and tangent inverse. Your calculator will probably require you to hit second function and then the trig function. So if we look at our notes here, we're looking to do the inverse tangent of 100 over 800. So inverse tangent of 100 over 800. And with your calculator, just to make sure your order of operations happens, make sure you close the brackets. And when you hit enter, you should end up with 7.125. Okay, now that's the degrees, or the measure of the angle in degrees. And if we round it to the nearest degree, we end up with 7 degrees. Really important, if you get a wonky number, check that you're putting brackets around that 100 over 800 in your calculator, and check that your calculator is in degree mode. Okay, let's try it a few more times to make sure we're on the right track. A road needs to be built that climbs up a large mountain. The road is going to be 6 kilometers in length and achieve an elevation gain of 1 kilometer. What's the average angle of elevation required for the road? So we've got some road that's going up a steep hill, and the road length is 6 kilometers, so make sure you identify that as the part that you would be driving on, not the horizontal distance. The elevation gain is 1 kilometer. And we're looking for the angle of elevation, so the angle from the horizontal up to the road. I'm going to call that label that angle theta. So from theta, I'll label my triangle. I know that this is the hypotenuse no matter where theta is. But from theta, straight across is the opposite side. And the one down below is the adjacent. We don't need the adjacent in this question, and we don't know it. So we're looking for a trig function that relates opposite and hypotenuse. You pull out your acronym here, SOHCAHTOA. Opposite and hypotenuse, the O and H, are in the sine function. So we write the sine of theta is equal to opposite over hypotenuse. Substitute in the values we know. Sine of theta is equal to 1 over 6. And now we got to get theta on its own, but it's being put through the function sine. So to undo that, we'll take the inverse sine of each side. So the inverse sine of theta just gives us theta, and we're left with the inverse sine of 1 over 6. And you can go ahead and type that in your calculator. Remember, second function sine, likely, and then 1 over 6. Make sure you put 1 over 6 in brackets, or use the fraction button. And when you calculate that, you should end up with 9.6 kilometers. Oops. No, not 9.6 kilometers. Sorry, we are not looking for a distance at all. We are looking for an angle measure, so that would be in degrees. So the average angle of elevation would be 9.6 degrees for this road. Here's a little list of things that you can remember or remind yourself of for solving these problems. So for all trigonometric questions, finding side lengths or angles, identify the angle you're going to be working with. It's either a known one or the one you're looking for. Identify the hypotenuse, opposite and adjacent sides. Circle the unknown that you want to solve for. Circle the known information, and then choose the trig ratio that matches those values you have circled using SOHCAHTOA, and then solve the equation. So there you go. Hopefully you've got enough to give these guys a try. I'll do one more with you right now just so you're on the right track. I know this is 15, I know this guy's 11. I'm looking for x. This is my angle of interest. So I can label my sides starting with the hypotenuse, because it's always the longest side, opposite of the right angle. And then from there, I can label the other ones, opposite and adjacent. And the trig function we're looking for needs to include the adjacent and the hypotenuse. So if you think of SOHCAHTOA, you would see that the cosine function is the one that works. So cosine of angle x is equal to the adjacent, 11.3, over the hypotenuse, which is 15. Now to solve for x, I have to take the inverse cos of each side. When I do that, I end up with x on the left and the inverse cos of 11.3 over 15. And you can put that into your calculator, and you should come up with a solution of 41 degrees. Good luck with the rest of your practice questions.